Welcome back to the Creation Reformation YouTube channel. This is Jake Ramgren coming back here with part 2 on my series titled Why a Reformation? Hopefully you've seen part 1 where I dive into the history of the scientific revolution and also some of the biblical reasons why there's a conflict between the story of the scripture and the story of the Bible and with the story of modern science. So we talked about a lot of different things for the last seminar. Just as a reminder, this is, again, a 3-part series. These are mostly unedited videos. I tried to make it to the last one unedited, but there was a problem with my slideshow, so I did cut out a portion of that. Maybe if you watched closely, you could tell where there was one edit. But for the most part, I want these to be completely unedited. I want to do these just in one go. I want to be cutting snippets out of these things. These are professional kind of style seminars, hopefully, and these full presentations. And as someone who has given presentations in both scientific, academic settings, and quite enjoy that. I've always enjoyed public speaking and these kind of things. I want that to kind of be a skill I continue to develop as I go along. So you won't see lots of cuts and edits here, again, unless there's some sort of problem with technology. I won't really be editing anything out. So hopefully these are smooth. Hopefully these are good presentations. I'm back here with part 2 of this series. I got more slides that are all over the place. I got more unsweetened iced tea with me. Apologies again for those of you who might be watching from the South, but up here we drink our iced tea black, we drink our coffee black, and that's just the way we do things. Just kidding, we just drink Sam Adams up here. All right, so part 2 is a focus on, if you can remember the way I broke down this series, this part 2 is a focus on the scientific evidence and the how the evidence is interpreted between the mainstream scientific story versus the biblical scientific story. And we're going to be comparing those two things. Again, the conflict, as I presented in the first part, the reality being a story, everybody telling stories to make sense of reality, whether that's from the ancient pagans or whether that's the Bible itself or whether that's scientific research. No matter how you try and interpret what you see around you, you're always going to end up telling that in a story format somehow. And as we've seen, science and the scientific method is no exception to that. When you're doing a scientific research proposal, you're telling a story that basically starts with your research question, and then you're exploring the research question, you're conducting experiments, and you're testing your predictions, and then you are describing the results that you got and why you got those results. And that's essentially a different version of telling a story. And so the conflict, though, of our story here, as we look at origins and creation and evolution, the conflict that many Christians have with this is that the story of modern science conflicts greatly with the story of Genesis. And now a lot of people will disagree with me when I say that. A lot of Christians out there will actually say there's no conflict. And I'm not going to dive too far into that right now because I think I've already covered that in part 1. There's a reason why part 1 ended up being an hour and a half long, and it's because I basically covered the history of the scientific revolution, history of science from its beginnings, really the history of the church leading up to the Reformation and beyond. And then I even spent some time talking about why I think that the scripture and story of the gospel and just the overall arching themes and story of the Bible do not match up well with the story of evolution. And so I've already explained that conflict. I've already gone into that. And so for part 2, which I've titled Wrath and Restoration, we're going to be looking at the scientific method. Now, part 2, being called Wrath and Restoration, is a reference to the global flood. And so once again, if you can remember how I ordered these series, part 1 wasn't just about the history of science. It was also about it also had a focus on creation, the event of creation in the Bible. And I connected creation with other parts of the Bible. I connected creation with the history of science and what the early scientists thought about the creation story and the creation narrative, whether it was a 6-day creation or whether it happened in a single instant, and eventually whether the days could be expanded to include millions of years in each of those biblical days. I covered all of that. So part 2, though, as we talk about the science, I'm going to talk less about Genesis 1 through 3, or even or even the creation event or narrative itself. And I'm going to focus a lot more on something that happens a little bit later in Genesis 7 and 8. And I'm going to be looking at the global flood, because the global flood, as it turns out, is going to offer a lot of answers to the scientific questions posed to creationists. It's all going to come back to the flood, basically, because if the universe is only 6,000 years old, the Earth is only about 6,000 years old, but we have so much data to look at. And at some point in Earth history, if there was a giant flood that covered the entire world, that flood is probably going to do, even thousands of years later, the flood is probably going to be that monumental event in Earth history that's going to explain all the data that we see in front of us. And so a lot of the biblical creation model is taking evidence that everybody agrees is there, but instead of explaining it through lots and lots and lots of time passing, we're going to explain it through a little bit of time passing through a catastrophic event that the Bible describes as happening. So again, we're building scientific models based on data that we see in Scripture. Okay, we as creationists value the data that the Scripture has, and it's a little bit unusual for a scientist to do that, but if a scientist had a eyewitness account from a human of what it looked like in the Jurassic period, right? Excusing, let's say, for example, that evolution, the whole theory of evolution as it's taught in science classrooms and in museums, let's say that whole thing is true. If there was a way that somebody would go back and live in the Jurassic period and then walked around and took notes about everything he saw and told stories about the Jurassic period, I guarantee you evolutionary biologists would take that eyewitness account and they would use that as data. Okay, they would use the eyewitness account as data to kind of construct their models of what Jurassic period looked like. All those depictions and pictures of the Jurassic period that you see in museums, those are guesses that scientists have put together. They're really good guesses, really accurate depictions, because they're based on the data, but they're never going to be perfect. And so what I guarantee you, if there was an eyewitness account, that account would be used by evolutionary biologists. And the only reason they don't use documentation by humans from those time periods is because there were no humans at that time in their model, right? There were no eyewitness accounts, so they have to reason backwards. Creationists do have to reason backwards a lot in our modeling. We have to look at the evidence that we see today and reason back to what possibly could have happened in the past. But we do have an eyewitness account. We do have a document, which is not just any document, but it's also a document that has been attacked more than probably any other book or account in the history of the world, and yet has still stood the test of time and is still used by millions around the world and is still held to be a accurate historical account. And so we have that. We have the book of Genesis that God brought down to Moses, told Moses, that Moses recorded on Mount Sinai. And so we have maybe Moses wasn't an eyewitness account of the flood, but God certainly was. And we believe God that actually spoke to Moses. And so it would be foolish of us not to use this account as data for ourselves, for our model building. That would be discarding one of the most solid pieces of evidence that we have. So even as scientists, it's okay to use, documentation from the past. The only reason mainstream scientists tend to not do that is because to them, a vast majority of world history took place before humans entered the scene, so we don't have any eyewitness accounts. So with that, let me get off this title slide and stop rambling here and dive right into this. I'm going to start with the mainstream view of the mainstream story. We're going to dive more into that. I gave a very, very brief overview of what the mainstream account of creation is in part one, but I'm going to dive a little bit more into that in part two. I think it's so important for Christians and creationists to have a good understanding of what the theory of evolution is, and how it explains the data and the information that we have. And you might be surprised by how I actually talk about evolution here. It's going to somewhat sound like I'm talking about it in a positive light, only because I want to show how elegant of a theory evolution is and how well it actually explains what we see. But as I go about, I just want you to know that even if I talk about evolution in this way, just because a theory explains what we see very well does not make that theory true. Okay, and at no point am I going to say the theory of evolution is the truth, or that that's how we actually got here. Quite the opposite. But I am going to dive into it. I'm going to give it an honest look instead of trying to completely tear it down every step of the way, or deny every single kind of piece of data put forth by the evolutionists. I think it's important to give it an honest look and dive into the history of it and what the theory of evolution is. So without further ado, let's take a look at that. It began in the 1830s, and it really didn't begin there. Evolution did not begin in the 1830s, but we're going to start there because something began in the 1830s, and that something was that Charles Darwin set sail on a voyage as a researcher. Charles Darwin was an Englishman, very educated. He was a naturalist at this point, right? He wanted to observe nature, and this was a great opportunity for him to do that. So he went on this voyage as a naturalist on the HMS Beagle, and you could see this is a map of his travels. It was a multi-year voyage, lasted about roughly 5 years. And at each stop, which there were many stops, they would stay for long periods of time at each of these stops, for weeks, maybe months, at each of these locations. And Darwin would leave the ship and he would walk around and he would make observations and write down notes in a series of notebooks or journals. And these notebooks that he would take notes on, he continued this even after his voyage. And he would simply start with a book that was labeled, I think it was A, maybe they were numbered, but I think they were lettered. He would just say A on the first one, and then when that was finished, he moved on to B, right? And he just filled up these notebooks with his observations. Now, most notably on the Galapagos, but he did do a lot of good natural research on things like the Falkland Islands as well. People don't realize there were other islands that he would stop at, other archipelagos. The Falkland Islands, I know, is particularly one underrated place. He made tons of observations there as well. But basically on these island chains that they stopped at, Darwin observed many species living on islands that did not exist anywhere else in the world. So he would come to a place like the Galapagos where there were multiple islands living in close proximity. And he observed species living on these islands that could not be, he knew they were not found anywhere else on the mainland. All right. So that's interesting. There's a term for this. It's called endemic, E-N-D-E-M-I-C, endemic. And these species are ones that exist on islands that don't exist anywhere else, or exist in an area and nowhere else. He also noticed that many of these species were very similar to one another. All right, he would find a tortoise on one island and a tortoise on another island that were different species, nowhere else in the world, but very similar to one another. Same thing with finches. Finally, he noticed that the small differences between these species were not random or just kind of there, but they were specific differences that allowed them to thrive in their immediate environment. So the slight differences that made one tortoise different from another tortoise also allowed that tortoise to eat certain foods or access certain areas rather than, the ones that lived on a different island. So tortoise, for instance, one tortoise might have had a longer neck to access food because the plants that were on its island were a little higher up, whereas another tortoise had a shorter neck because the plants that it was eating were on the ground or closer to the ground. It did not need a longer neck to eat the food that it found on the island. So this is very, very curious for his time because most naturalists of his day believed in something called species fixity, which is that every species basically does not change. When it reproduces things that are exactly the same as the parents. Every species is completely fixed, and they were also, usually most people at the time believed that they were designed that way by God from the beginning. That God created these different species, and He created them the way that they were then. So this is a very curious observation to make, which is if God, and I'm getting ahead of myself here. Let me see. Yeah, no, I can get into this. So when Darwin made these observations, what he's basically wondering is, if God created all these species fixed, why did he put some of them on islands, nowhere else in the world, and just have a bunch of them that were kind of clustered on these islands, nowhere else in the world, but just there? Why would he make them closely, very, very similar, but with slight differences? This seemed very, very arbitrary and not very designed. He didn't see the design. And one of the reasons why people believed that that creatures were designed is because they looked designed. They looked like they were created for the environment they were in. But the observations Darwin made did not seem to fit that view, because you had endemic species that, again, that if you believe that God created them fixed, you believe that God created a bunch of different tortoise species on these islands, a bunch of different finch species, each one on their particular island, and just decided not to put that finch anywhere else in the world, did not put that tortoise anywhere else in the world. And so why would he make island ecosystems so different from mainland ecosystems? Now, he had many influences leading him up to when he eventually proposed his theory being that instead of God putting tortoises and finches on those islands, there was an ancestral finch species that landed on those islands, an ancestral tortoise species that landed on those islands, and then they diversified and evolved each one to fit each of those islands. And then the mainland's original species died off. And so it was found nowhere else on the continent, but they did thrive on the islands, and so now they're found on the islands and nowhere else. So he did have his influences in constructing this theory. For one, evolution already had been proposed by Jean-Baptiste Lamarck, a French naturalist, obviously. And his view was called the inheritance of acquired characteristics, which is that a species could evolve basically by obtaining new traits in their lifetime and then passing those traits on to the next generation. So the most classic Lamarckian example is that he proposed basically that a giraffe used to be a smaller animal that didn't have a super long neck, but then it needed to stretch out its neck to eat food. And so as it stretched out its neck actually grew a little bit longer, and then it passed down that longer neck to the next generation. That next generation, they still needed to eat food that was even higher up. They stretched their necks got a little bit longer, and then they passed down those longer necks on. Eventually you get a giraffe, which is 20 feet tall and has a super long neck. That was Lamarck's view. And Darwin had known about Lamarck's view and had criticized it before. But the fact of the matter being, evolution had already been proposed. Another influence of Darwin's was the book Principles of Geology by Charles Lyell. And this was a geology book, yes, so it didn't have much to do with evolution, but what it did do was propose that the Earth was very old. Now, I could totally dive into a rabbit hole here. I'll just keep this quick. I do want to note, Principles of Geology being written before Darwin. This means that scientists were already proposing that the Earth was very old even before evolution came about. And I think I want to bring this up as an important point because a lot of creationists tend to think that it's really, really foolish to believe the Earth is old, that God specifically designed the world to look young. Everything looks young. All the evidence points to a young Earth, and that the only reason someone might deviate from this is if they are, if they don't want to believe in a God, or they put their preconceived philosophical ideals before their research or before they decide what to believe, and that the only reason they discard a young Earth is because they want to. And I think that this can actually cause some harm in how we actually present our own ideas. If we kind of start from the position that the other side is only believing in their side because they hate God or don't want to believe in a God, and that they're just completely on the wayside, that's going to come across poorly to the people that we're trying to convince of our position, especially since I don't think that line of thinking is true. Charles Lyell was not even the first person to propose an old Earth either. He was the first one to maybe publish a profound kind of comprehensive view of geology from an old Earth perspective. But even John Wesley Powell, who is actually one of my heroes. I love John Wesley Powell. He was the first man to explore the Grand Canyon. He had one arm. He was a veteran of war, and he took a small group of men through the Grand Canyon to explore it. Very nearly perished on this journey. But and again, I love Western history, so he's one of my heroes. But even as he passed through the Grand Canyon, he looked at these layers, and he has written about how those layers look like they're millions of years old, because it's hard to imagine the Grand Canyon being formed in a short period of time. So I don't think it's fair to say that it's foolish to believe in that the Earth is old, or that it's just something that it's just your bias speaking. I'll put it that way. I think you can look at the world through an unbiased perspective and come to the conclusion that the Earth looks old. Okay. And I think that's part of the reason why an old Earth is accepted by virtually all mainstream publishing academic scientists and institutions. I think it's not the whole reason, but I do think it's part of the reason. So let's keep that in mind. Old Earth ideas were present before Darwin, and they actually influenced Darwin, because now Darwin's thinking, whoa, this Earth is millions of years old. I have millions of years to play with as he builds his theory. He doesn't need to explain evolution in a short period of time. He's looking at the natural world, he's looking at these organisms, and he's understanding already that these organisms have existed as species perhaps for millions of years. And so this is influencing him as he's putting together his theory. His own grandfather, Erasmus Darwin, had already written about evolution as well. So evolution is already on the scene before Darwin arrives. So again, here's his proposal, is that each species is not fixed, but has actually descended from an ancestral species that it shares with other species. So each of those tortoise species are cousins that diversified from an original tortoise great-great-great-great-grandparent. They're different species, but they are related. And if you read The Origin of Species, which is one of the greatest books on science that has ever been written, he talks about how variations between even siblings in the same family are very, very close to variations between different groups within a species. And then those differences are very much like each species to each other. So he's starting to look at things as very malleable and changeable. He had also read Thomas Malthus's essay on competitions between humans for limited resources. So Thomas Malthus had written an essay. He was not a scientist; he was an economist, and he was writing about how if you have limited resources in a society, you're going to have competition for those resources, and basically the people who are best at getting those resources are going to live longer and live better and and reproduce more. And the people who have a hard time accessing those resources, getting food, the people who are poor, they don't have resources, they're not as naturally aggressive or inclined to attain resources, they are going to struggle. They're not going to reproduce as much. They can't afford to. They're going to starve more often. And so you have this idea of the fittest people surviving the best because they can access those resources. And that's kind of a paraphrase. I might not even gotten everything right. I haven't read that essay, but that was one of Darwin's influences. So Darwin took Malthus's idea, his mechanism. He incorporated Lyell's view of millions of years. He didn't really like Lamarck, but Lamarck's evolution had already been proposed. Those evolutionary ideas, right? The ideas of his grandfather. He took evolution, he took Malthus's essay, he took Lyell's millions of years, and he put them all together to basically propose a comprehensive view of the history of biology. Now, his voyage has been over. He has all these observations of these different species. He's thinking about, why he saw what he saw in the data, and he comes up with this idea of natural selection, that species, when they compete for resources, right, when individuals compete for resources, the fittest survive. The ones that are not able to access the resources die off. And certain traits that are good for survival actually last and spread to the whole population, whereas the traits that are bad for survival in that environment die off. And this is natural selection. And this idea of natural selection, which is an incredible idea, really, this mechanism can explain how you get an original species diverging into different new species. How one finch can become one species on this island and a different species on that island, because each island has subtly different conditions. And with subtly different conditions comes different traits that work best for that environment. And so the variations that have that trait are going to survive and reproduce, and the finches that do not have those traits are going to die off, and eventually you're going to get populations that look distinct and different and can be classified as different species. So after his voyage, Darwin spends the next 20 years doing research and collecting data. Now, he had not published anything particularly of significance in the scientific realm. And so I can dive. So I've read, I never read biographies, and the one biography I have read is on Charles Darwin. So I could definitely dive way too far into Darwin's life and his history. I read The Reluctant Mr. Darwin by David Quammen, which was fantastic. Like, I highly recommend that book. So I could dive way too far into this. But basically, Darwin spent 20 years doing research, and some of this research was to prove, basically, he wanted to prove he could be a good, reliable naturalist scientist before he proposed his idea. Because if he proposes his theory and he hasn't published anything significant or noteworthy, he hasn't proven himself as a scientist yet, he's worried that his radical idea is going to be rejected, not because the idea isn't good, but because he isn't a professional scientist. So he did 20 years doing other research. He actually spent, I think, 8 years studying barnacles, to the point where he was so sick of studying barnacles, he wanted to destroy all of his barnacles and throw them away. He studied tons of barnacles, published papers on barnacles, right? Proved that he could be a scientist. And then his plan was to publish a ginormous volume of his idea of natural selection and evolution. And then he would be, it would be more accepted. People would be more susceptible to accepting it because he was a professional scientist. But his whole plan, this was his long-term plan. He's spending years of his life putting this together. And this all gets sidetracked because Alfred Russel Wallace, who had done some work in the Amazon rainforest, sends him a letter. And Alfred Wallace at this time was an up-and-coming scientist. He was one of the younger ones. He was just excited to be a scientist. He was actually thrilled that he was a colleague of Darwin, and made him super excited. Just to be in the room, with the Charles Darwin, because he's an up-and-comer. He just wants to make his mark, right? And so he goes out to the Amazon, and he has this fever dream in the Amazon where he's sick, and he comes up with this idea that is identical to Darwin's. And so he sends a letter to Charles Darwin proposing the same exact theory. So at this point, Darwin freaks out because he's been doing 20 years of research, and he's been compiling his work to publish this idea, and now he realizes that he might get beat to the punch. Alfred Russel Wallace might publish it first and become the founder of evolution theory. So Darwin pulled together everything he'd been working on so far. He published a volume which he called his abstract, but what we know today as The Origin of Species. Or, if you want the full title, The Origin of Species by Means of Natural Selection, by means of the preservation of favored races in the struggle for life. And that's the book that we know. And as you might know, he does not actually end up publishing a fuller, larger volume. The Origin of Species is his quote-unquote abstract, and that created a ginormous storm in the scientific community, and he never actually went back and published a full volume, though he did write other books kind of focused on different parts of evolution for the rest of his life. But that's the origin of species. In The Origin of Species, he writes, I believe this is the last sentence of his book. He's never one to write short sentences. But in the last sentence of his book, he writes, and I want you to remember this, there is grandeur in this view of life, with its several powers, having been originally breathed by the Creator into a few forms or into one, and that, whilst this planet has gone cycling on according to the fixed laws of gravity, from so simple a beginning, endless forms most beautiful have been and are being evolved. So, His proposal of natural selection evidently explains how a species can evolve. And because the degree of difference between individuals is not very different from the degree of difference between variations, because the difference between variations is not very significant significantly different from the degree of difference between species, the degree of difference between species is not that great from the difference between genera. He put the whole thing together and said, look, there's no great degree in differentiation between each of these levels. So all of the levels are ultimately malleable. And if given enough time, difference in variations can become difference in species. Difference in species can become differences in genera. Differences in genera can become differences in families. And it's all the way up to kingdoms, to the point where all living things came from an original common ancestor or ancestors. He said one or a few, right? One or a few ancestors, which conventionally now evolutionists would say one ancestor, one single cell eventually replicated and became all of the living things that we see today. So another thing that we as creationists need to come to terms with and take an honest look at is why Darwin's theory was so influential. Why did it transform the world in a way that Lamarck or Erasmus Darwin or Charles Lyell or Thomas Malthus, why did his idea take the world by storm? Part of it is because of how monumental the idea was, that it gave us an origin of living things that had never been proposed before. Part of it was because he gave a mechanism of natural selection that actually worked to explain how species evolved. And part of it was because of how much it actually explained. So let's dive into this. For one, evolution explained the order of the fossil record. The fossil record is a term we scientists use to describe how the geological strata that we see, different rock layers, how they are ordered. So we see the same basic order of rock layers and fossils throughout the world. We don't see the whole geological record in one place, but we see different sections of it everywhere. In different places, you can see certain layers that have been laid down. And you can match up the layers with each other based on the composition of the strata, which just means rock layer, and the types of fossils you see in the layers. And so with that, you can look at different portions of strata all around the world, and you can compile this into something that we call the fossil record. And then you can label all the layers, you can label all the fossils that you find in them, and you basically get this grand idea, this total collection of rock layers found from across the world with fossils found from across the world. And this is like a snapshot of the world as it used to be, right? These fossils used to be living things that lived in the places where they were deposited, maybe where they were deposited, maybe they lived somewhere else and were carried there from somewhere. But this is a snapshot of our past. And this is a lot of the data that we're going to use to reason back to how things got to be the way they were. And evolution explained the fossil record very well. And that's because evolution explained why you got certain fossils at the bottom of the fossil record and certain fossils at the top of the fossil record. It explained the order, right? The animals at the bottom of the fossil record evolved first, and then they slowly continue to evolve and live and explain the layers that were, further on. Each layer representing a long era of time, the fossils in those layers representing the animals that lived during that time period. So though many were skeptical of Darwin's theory, it aged extremely well. The order of the fossil record basically fit right into Darwin's model. And then later on, modern dating techniques, all forms of radiometric dating, potassium argon dating, carbon dating to an extent, but I'm kind of pulling a blank on what all of them are called. Lead dating. There's all sorts of dating methods that are radiometric dating. These have come about since Darwin's theory, and they all propose timelines that pretty much agree roughly and fit well roughly in the story that Darwin told. Scientists can now even look at the different species. They can look at genetics, and they can organize the species into what are called phylogenies. which are basically family trees, where species that are closely related are on two branches that diverge from a common ancestor, and then the ones that are more distantly related are on branches that are far away from each other. And so you can organize all the living things onto basically a family tree in the same way we can organize our own families into a family tree. You can organize species into trees of how they're related to each other, which ones split from which common ancestor, how long ago. And these phylogenies, broadly, when you look at them, and here's what I want to explain. The phylogeny is its own method of constructing history of evolution. You can, without looking at the geological record or the fossil record, you can look at a group of organisms and you can look at the genetics and you can construct a family tree and say these two are more closely related than these two are because they're genetically more similar. And you can build a family tree just looking at the genetics. Just like we do with family histories. You can look at the genetics of a family and tell their family history, who's related to who and how, without looking at yearbooks and without looking at historical documents. So this is its own set of unique data. And these phylogenetic trees, more often than not, follow the predicted order of evolution based on the fossil record. So this is why you hear evolutionists say, we believe in evolution because different fields of science match up and perfectly explain natural history, right? It's not just they don't just have to look at the fossil record. They can look at genetics and that these phylogenies, and they, independent of one another, correspond and correlate and fit this evolution story. And Darwin didn't use phylogenies at all. He didn't even know about genetics, right? He didn't know about DNA. So this is pretty compelling, stars aligning evidence here that fits basically that the evolution theory explains well. It doesn't prove evolution, in my opinion, and I don't think you can argue that it does, right? I avoid the word proof as much as I can because proof is an unrealistic standard for really anything. But it doesn't mean evolution is true, but evolution explains these things very well. And again, they're corroborating, is that the word? Between different fields of science, and they're matching them up together. And each one independently is explained by the theory of evolution. Darwin also predicted that we would find transitional fossils. The fossil record did not have really any transitional fossils yet in Darwin's day, but Darwin knew there was much more to be discovered. There were many fossils that had not yet been found, and he said we will find fossils that show species in transition, or kinds of animals that are halfway one animal and halfway another animal, because it's showing a transition between one species to another. And over time, we actually have found some fossils that look to be transitional. This guy right here is called Tiktaalik. Tiktaalik is a fossil that looks like it's a transition between a fish and a tetrapod, which is basically a four-limbed animal that lives on land. And it was basically evolutionists predicted they would find a fossil that looks just like this guy, and they said they would find it in this particular rock layer. I think it was Devonian. We're going to find it in Devonian rock layers in the Canadian Arctic. That's what they predicted, and they went out and they looked for it, and they found it based on their idea of evolution. They said if fish are in this layer and tetrapods are in this layer, somewhere in here we should find a fossil that looks like a transition from fish to tetrapods. And they looked and they found this fossil. That this is a pretty good representation of it. And I've seen fossils of Tiktaalik in museums. It's a pretty popular fossil. There's one, and again, I do museum tours from a creation perspective point of view in natural history museums, and Tiktaalik is pretty regularly in those museums. There's one at the Yale Peabody Natural History Museum, and there's a really good one there. And I think there's also one at the Harvard Natural History Museum in Boston. So Tiktaalik was a very effective transitional fossil that really seemed to confirm evolution theory. So, all right, I'm going to stop sounding like an evolutionist for a minute. I'm going to stop trying to sell you on the idea of evolution. I'm not selling you on the idea of evolution. I'm selling you on the fact that it is okay to say that the theory of evolution explains a lot of the evidence. So the question is not how should we refute that evidence. The question is not how do we prove that evolution is all bunk? The question is, how should we as creationists who are standing firm in what we believe in the Bible? Remember, we have an eyewitness account on how things were. We have God telling Moses on Mount Sinai how things were created. So we have the most significant piece of data that is on the planet that is saying one thing, and then we have the modern scientific models that look very, very convincing and effective saying another. So how should we as creationists who would rather take what the Bible says, how do we interpret the evidence that is already being interpreted very well by a different theory? Now, we have the same fossils to work with. We have the same genetics to look at. We have the same radiometric dating processes. We have the same rock layers. Everything we're looking at is the same data. But that doesn't mean that the evolution story is true. It just doesn't. Like, it's a great, powerful explanation of that data, but it is not the true explanation of that data. Because we know this because the Bible presents a different story as an explanation for that. So how do we as creationists interpret the data differently? We build a young Earth model. This is what creationists are trying to do, or creation scientists. We are trying to build a comprehensive model that works just as well as the theory of evolution at explaining the patterns that we see in creation in the natural world. So I'm going to take us through briefly geology, paleontology, and biology. I'm going to do this in a way that I hope is really honest. I'm going to explain what the young Earth model says about these three things, and I'm going to honestly compare them to the way that the mainstream view of evolution explains those things. Now, caveat, full disclosure, Jake Ramgren, being completely honest with you, my background is in zoology. That's the last one I'm going to cover. So the biology stuff, I can call myself more of an expert on at the end. I have done some research in the area of creation biology and presented at some conferences, and I have an abstract published in the new journal, New Creation Studies. So I'm somewhat, you could call me somewhat an expert there. I don't have a master's or a PhD or anything. I know a lot about creation biology. Geology and paleontology, I've read papers on. I've heard experts give their research on it, presentations on geology and paleontology. So I'm going to run you through the basic creation model of geology and paleontology. I am not myself a geologist or a paleontologist, and very often when I'm sitting at these conferences and I'm seeing, creation geologists giving these presentations, I very quickly get lost sometimes, and I don't know some of the terminology, and I don't have a deep understanding or grasp on geology or paleontology, but what I do know is the creation model's explanation of why we have rock layers and the fossil record. And so I'm going to explain to you that, right? So you're basically going to be kind of on the next level of understanding if this is something you've never heard before. And again, this brings us back to the flood. If you recall, evolution and creation are two competing stories because everything is a story. The creation story relies on a catastrophic flood that covers the entire globe. And that's how this creation story explains all of the data, virtually all of the data that I just ran down for you. I just told you about rock layers. I just told you about fossils. I just told you about transitional fossils that look like they are evolving. I just told you about all this data that seems to confirm evolution. But there's an alternative story, and that alternative story is that instead of millions of years of time and evolution happening, there was one dramatic flood event. And the flood explains the geological, paleontological, and biological evidence for evolution. All right? So again, I'm not an evolutionist, even though I believe in all the data that I've just described, even though I believe in the fossil tiktaalik, even though I believe in the radiometric dating techniques. The flood is going to give an alternative perspective on all of that. The flood, briefly here, the flood explains how we get the geologic column. Because during a flood, if you're going to cover the whole world in water, it's going to get really muddy. It's going to pick up a lot of sediment, which is what rocks are made of, right? Or at least what sedimentary rocks are made of. It's going to pick up all this sediment, and it's going to lay down those sediments in layers. Even local disasters do this. Local floods, local storms, local volcanic eruptions, anything that stirs up the ground and picks up a bunch of dirt and sediment and mud and deposits them, it's going to do it in layers. The flood is going to also pick up animals that are living in these areas. It's going to pick up the sediment and the animals living within it, and it's going to bury those animals in sediment. And what happens to animals buried rapidly in sediment? They fossilize. Animals don't fossilize when they're roadkill on the side of the road, right? Animals don't, when they die, they don't just fossilize. They don't just become a fossil. It takes very specific conditions to make them a fossil, and the flood matches these conditions well. So in the older story, you have these conditions are only met very rarely. But because you have millions and millions of years, those conditions are met here and there. You're going to have local floods, pretty big floods, but still local, not worldwide floods. You're going to have floods, you're going to have flash floods, you're going to have mudslides, and you get fossils every once in a long while. But because you have so much time, this racks up to billions of fossils, which is what we have today. But in the flood, you have a short amount of time, but you're going to get a ton of fossils because the conditions are met for fossilization around the whole globe. Hopefully that makes sense. And then after the flood, when God tells the animals on the ark to spread and replenish the earth, this actually gets to where my kind of expertise is in, which is in speciation after the flood, or diversification after the flood, of how do species, how did the animals on the ark change and adapt to fit the conditions that were there after the flood, so that in only a few thousand years, we get to many, many species perfectly adapted to their own conditions, just like the tortoises and the finches that Darwin observed today. How do we get to that point from the flood? So the flood is going to basically shed light on all three of those areas: geology, paleontology, and biology. And I'm already knocking on 50 minutes. Good grief. Let's get into this and get you this understanding of creation geology, paleontology, and biology. Let's get into it. All right, so geology. What is the evidence that we have in geology? In geology, we have geological strata, which means layers, that are found all over the world. These layers are identified and organized into something we call the geological column. I've already explained this. I've also already explained that the conventional story, and this is one of the seminars that I used very early on in my creationist speaking career. I wish I'd used the word conventional, but the word secular works. The secular story, or conventional story, says that each of these layers represents an era of time. Entire biomes lived for millions of years and deposited sediment onto these rock layers onto the rock layer that came before it. Thus, the geological column represents Earth's entire history, with each layer corresponding to an era of time. Okay, and so this shows you, and that's not even quite explained the way I should. I might have to go back and rewrite these slides, but basically each layer represents a snapshot of a long period of time that happened in the past. And this sediment has been laid down by, again, local floods, local mudslides, just local geological events that basically laid down the sediment. And then after millions of years, that builds up, and then eventually the biome changes, conditions change, and then a new layer starts to begin to form on top of that one. And so you have the geological history is millions of years of sediment being laid on top of itself to form different layers. And you can name these layers because you can recognize these layers in different areas of the world. So I can look at Mesozoic layers, right, where the dinosaurs lived, and I can look at a layer and say, hey, this is Cretaceous because it has these type of fossils in it, and it's made up of this type of rock. And then I go to a different part of the world and I notice those same type of fossils and the same type of rock, and I say, hey, that's Cretaceous. And in every instance, Cretaceous is on top of the Jurassic, and it's below the Tertiary, which is part of the Cenozoic. So all these words mean something. I'm not going to dive into all of that, and but that's the conventional explanation. But meanwhile, the creation explanation is different. We have the same. I have a box there that says the evidence. The evidence is exactly the same. I didn't change a single word. We have the same evidence, but the biblical story says that each of these layers was deposited by a worldwide catastrophe in the days of Noah. Flood waters picked up sediments all around the world, laid them down rapidly into layers, which were then solidified and hardened into rock. Thus, each layer is not an era of time, but a different sediment type deposited during the global flood. And now, and you can see, this is where there's some controversy among creationists. We don't actually all agree on which layers were during the flood and which layers were after the flood. But we all agree essentially that the layers are there because of the flood, and that explains. And this is the one. This is what we call a lower Cenozoic flood boundary, which is basically that at the top of the Mesozoic, when all the dinosaurs go extinct in the conventional timeline, right when that's where the asteroid hits the Earth and wipes out all the dinosaurs. That part of secular history is where the flood ends in the creation model. And after that, the fossils that we find after the Mesozoic, after the flood, are fossils that are deposited during ginormous catastrophes that happen after the flood. So catastrophes do not end when the flood ends. You have large floods happening afterwards. You have volcanic eruptions happening afterwards. You have big catastrophes happening right after the flood because the Earth just suffered a giant catastrophe and is still in a very unstable condition. And so many fossils do get buried after that flood period. So before the flood, the Precambrian layers before the flood kicks in for the Paleozoic and the Mesozoic layers, which basically means, from the Cambrian explosion up through the dinosaurs. And then post-flood catastrophes bury fossils in the Cenozoic, and the Cenozoic leads right up to today. And so that's where that's what you can see here in the creation model. I myself subscribe to a lower Cenozoic flood boundary for reasons I can't get into right now. But there are creationists who would say that even the Cenozoic is flood model is during the flood, and it's only the upper Cenozoic that is where the flood actually ends. So there's arguments for both sides of that. That's a certain discussion happens among creationists, but basically the creation interpretation of the geological record is that these layers were laid down during the global flood. And now I'm going to get into the exciting part, which is some evidence for what I'm talking about. But take a look at this picture for a second. This is from Is Genesis History. And this shows you, this is a great picture that shows you basically flood sediment. So you can see the ground, the regular old ground that is Precambrian. And that is land that was created during the creation week. Okay. Might not have looked exactly like that during creation week, but that land was there from the beginning. Then you can see, just look at, this picture, you can see the flood happening almost in your mind's eye in real time. You can just see it in your brain. A big flood came through and deposited all of this new sediment right on top. Okay. You can see it. And if anyone asks you, you can seriously I don't know if YouTube will let you, but you could screenshot this. And if anyone asks you to show them evidence of a flood, show them this. And unless they're like a hardcore, geologist who's going to break that down and explain it from a different point of view, this looks, to anyone, this can look like a significant flood that came through and deposited all the sediment right on top of that Precambrian rock. But I'm not just going to show you pictures and say, hey, look, flood. We're going to get into it a little more. We have some evidence in folded rock. Now, again, this PowerPoint is a little bit outdated. I'm going to add a little bit more to it than when I gave this presentation at PVCA years ago. But rock layers, a lot of them in the Grand Canyon and other places, rock layers are often folded. They are not horizontal, perfectly horizontal. They actually fold. This is a good picture of that, also from his Genesis history. And here you go. I wish I had fixed this slide, but because that's another good photograph of folded rock that matches up with this depiction. This picture is from Answers in Genesis. But rock layers across the world basically have showing evidence of being folded. Now, rock layers can only fold under certain conditions. Obviously, they did not fold during the millions of years of Earth history. This is not how the layers would have been laid down. You can't have, for instance, a biome living like that, right? You'd have to have them living kind of bent or sideways. Like, this is not how things work. Geology works. You would need the layers to be laid down over millions of years or during the flood, and you would need those layers to then bend afterwards, after they were already formed. And this can happen under two conditions. It can happen if the layers are not quite solid rock, but are actually moist. If they're wet, if there's water mixed into the sediment, that makes the layers pliable, right? They're flexible. And so if you have a flexible bunch of layers, right? You have this geological column, and if they're wet and soaked through and flexible, then if there's an earthquake and the lithosphere, which is like the layer under the ground, if the layer underground shifts and there's an earthquake, the pliable layers on top will bend and can fluctuate. And so that is a pretty consistent explanation with the flood. The flood deposits the layers, and then the flood water recedes, and it leaves these rock layers soaked through, right? They're not underwater anymore, but they're still wet. They're still pliable. They're still able to move. And so then an earthquake happens. The lithosphere shakes. The earth is still recovering from the flood, and so there's lots of earthquakes happening. And when an earthquake happens, the ground shifts, the crust can break or can crack and move around, and then these layers actually fold and can form formations just like this. You can see here where the certain parts of the crust dropped down, and then the layers folded. What can also happen, and in the conventional theory, these layers are never wet. They were laid down, and then something happened that folded them. There was never a giant worldwide flood. And so their explanation is that there was volcanic activity that heated these layers up a lot and made them very, very hot. So volcanic activity makes them very, very hot. And hot rock melts just a little bit, and it's kind of like magma, right? And this is very, very hot rock that can also fold or bend if there's some sort of earthquake or geological event happening. And this explanation would also work very well. Here's the thing. Let's see what slides I have. Here's my sources. I always try and cite my sources here. This is Andrew Snelling. He was a creationist with Answers in Genesis, a researcher for a long time. He's now retired, but he did a research project, and this is actually a good slide to sit on while I kind of explain the rest of this argument. So basically what can happen, though, geologists can look at a rock, and they can look at it under a microscope, and they can tell if at one point it was very, very wet and there was water mixed in, or if at one time it was very hot and it started to melt. So Andrew Snelling and some other creationists actually went down into the Grand Canyon. You can watch all of this in the movie Is Genesis History, the second one called Mountains After the Flood. They went in, they took samples of rock, they looked at it under the microscope, and they found evidence of basically what's left behind when water soaks through the rocks and makes them wet, and then the water eventually does leave, but it leaves behind markers that the water was there. And they found these markers. Okay, they found these things called ooids. They're little kind of circular discs in the rock, or are they sphere shaped? I don't remember, and I'll have to go watch the movie again. But they went in and found these ooids, which are evidence that their water seeped through the rocks, and that would not be there if these rocks folded through volcanic activity by itself. And so they actually found really compelling evidence that these rock layers were formed and then folded after the flood receded and left these rocks wet and susceptible to folding during geological events like earthquakes. And that research is published. These two papers should do the trick, but there's plenty of others out there. Keyword search on Answers Research Journal or other creation websites, and you should be able to find this research pretty accessible. It's great research. Again, watch Is Genesis History. It's some free advertising on my end, though I am somewhat associated with Is Genesis History through the New Creation blog. But go watch that movie and see exactly what they did. It's very compelling evidence for a worldwide flood. Here's another one. This one's actually going to be somewhat controversial among creationists because, like I said, some creationists are going to disagree with this interpretation, but I think this is very compelling evidence of a worldwide flood. We have post-flood lake formations. Now, I've seen creationists publish work saying that this lake doesn't exist, and I have to disagree with that from my non-expert perspective as a creation zoologist. But basically, when the floodwaters recede, the floodwaters are going to leave giant bodies of water behind. And that's where we can find. So in conventional thought, right, even dating back to my hero, John Wesley Powell, people thought that the layers were laid down over millions of years, and then the Colorado River going through the Grand Canyon cut away at the land for millions of years, and through erosion revealed the Grand Canyon. Creationists believe that the Grand Canyon was cut out either during the flood or after the flood. And I'm going to say it happened after the flood because this research project, really, really good research here. I was blessed enough that my first creation conference I ever went to, this exact picture was up on the screen. This presentation was being presented. And I didn't even realize how significant it was when I was there. I was kind of like, okay, there was a lake. But this actually is evidence of a dramatic, catastrophic event that happened shortly after the flood. So if you look at this picture, the blue arrow there in the top right corner is pointing at the Grand Canyon. So all of that, you can see the Grand Canyon right there. It's winding away. And then what I'm about to show you is where this lake was that was left behind by the flood. And if you look at it carefully, you might even be able to trace it out. If you printed out this slide, you can probably trace out where you think the lake would be. But I did it for you, and here it is. All right. So this is a giant lake. This lake is called Hopi Lake, and it was left behind when the flood receded. Then you can see exactly where this flood breached, and this ginormous flood occurred. That's not a worldwide flood, but shortly after the worldwide flood, this lake breached, and the waters rushed out and carved away at the Grand Canyon quite rapidly. And this research has been published. Steve Austin is a very well-known creation scientist who worked with Nate Loper and a few others on this. And they have drone footage, they have pictures, they have all sorts of data showing that there was a lake here. And this lake breached and carved out the Grand Canyon. And how significant is that research? We have creationists on the ground explaining the origin of the Grand Canyon. The Grand Canyon itself, we have a great explanation for how this happened. We have great evidence that there was this lake up here and that it carved out the Grand Canyon. Now, again, some creationists are going to tell you that this all happened during the flood and not after the flood, because this was something that happened during kind of the Cenozoic timeline. But I tend to be compelled by this creation research here showing evidence of this lake that carved out the Grand Canyon. Either way, wherever your flood boundary is, creationists have a great explanation for the Grand Canyon being cut out rapidly rather than over millions of years through the Colorado River. This is really, really good research. And I just want to point out here, and I'll probably repeat this later on, but if creationists are completely on the wrong track, the theory of evolution is 100% true, and we're the crazy ones, we shouldn't actually be coming up with, these great, like these are really, really strong projects, and they're positive research that is being published, and that's really hard to explain why we're coming up with really good research like that if we're completely on the wrong track. Now, I've already said that, just because a theory explains the data doesn't make it true. That's still the case here, but it's really, really encouraging that we're doing science based on our data in the Bible. And if the Bible's if the Bible's just ancient religion, ancient myths, and then using that as a basis for scientific research should be completely a completely wrong, broken idea. And so we shouldn't actually be coming up with these ideas based on, how you've heard people talk about the Bible, like the thousands of years, like we just trust the words of people who wrote down these things, thousands of years ago, and during when they still believed in a canopy and a Earth at the center of the universe and a flat Earth, whatever. The way that they talk about the Bible, if we're going off of that Bible and we're doing scientific research, and the Bible is what they say it is, and it's completely bunk and it's completely scientifically hopeless, then our research should be hopeless too. But it's not. We're coming up with really good research projects. It's coming up with really, really good data. And here is another depiction of Lake Hopi, and from a different angle. Now Grand Canyon is in the top left corner. I added the labels there to help you out, but that is a figure that is from this research article that is there. I will actually go through and use I cited all my sources here. I'm not an expert on some of these things, but I'll stick them down in the description to this video, and you can access those articles yourself. I believe all the ones I got were free open access. And so I'll have those down there for you. But there's Lake Hopi. It breached, carved out the Grand Canyon. This is a great model. I don't know what to tell you. I think it's, to look at this honestly, you have to admit that this is a good scientific model. Oh, and I'm going to have to go through and add all these because I have more papers for you. But Nate Loper, again, has done a lot of work on this. John Whitmore, Kurt Wise. These are Steve Austin. These are good creation scientists who have constructed some great models here, and those will all be accessible to you. Go take a look at this. Spillover erosion of Grand Canyon. This is a great model. I don't know what to tell you. Okay, this one I've added in. This was not part of my original presentation on this exact. This was not in the original part 2 of this series, but I had to throw it in here. The log map theory of biogeography. One question creationists and conventional scientists must answer is, how did the certain species get on these islands? How do they get there? How do they get there from the mainland? Creationists must explain it because all animals came from the ark, and when the ark lands, it's on a mainland, so animals must get from the mainland to the islands. For a conventional scientist, you have millions of years of continental drift where continents broke apart and spread apart from each other, and they have to explain how animals got from these mainland to these chains of islands. And so creationists did some work on this, and they came up with an idea called the log mat model. And this was come up with some names that I've already mentioned today: Steve Austin, Kurt Wise, who from all the way back to the 1980s or 1979 there, they proposed that after the flood uprooted all the world's trees, and these trees would actually float on top of the water, and they would collect, maybe because of currents. Ocean currents carries all the logs to the same places, and they would create these giant mats that are so full of layers of trees that large animals could even hop right on top of these log mats and travel to other parts of the world. And if you look at, I should have included this, but if you look at a map of the world with the Earth's currents, you will see that the major currents in the ocean would actually, if you just rode those currents, you would actually run into all of the major islands that contain lots and lots of life. And there are some island chains that are not connected by currents with the rest of the world, and they tend to have a lot less living things on them, a lot less plants and animals. And so it makes sense that animals hopped on these log mats, and these log mats transported them to other places. And then when these trees decayed and rotted away in the ocean, and eventually the organic material, broke down and sank to the bottom of the ocean or disappeared, these animals were stranded on these islands, and the animals that were on the mainland died off. And you basically have Darwin's exact questions answered on how like a finch species could get onto the Galapagos and diversify there. You have an answer to that, right? You have a creationist coming up with a model that fits this perfectly. And so this is significant. And here in 2006, you have a paper from a conventional paper using that rafting idea to explain how animals got to islands. So you have creationists actually beating evolutionists to the punch here in coming up with a model for biogeography that is now being incorporated into conventional literature. So that's something that really excites me. Again, if we're doing science based on the Bible, and if the Bible is completely bunk and is completely scientifically hopeless, then we should not be coming up with these really good scientific models that are so good that they're even being used and taken by conventional scientists. This shouldn't really be happening if there's nothing to the Bible but superstition. All right, so let's move on to paleontology and the fossil record. It looks like might even pass the hour-and-a-half mark from part one, which I was hoping not to do, but here we are. Credit to my brother Nate for taking this great picture. If you want to see this exact dinosaur footprint, come on down to Forest Park in Springfield, Massachusetts, and they have these dinosaur footprints. They're really, really cool. I visited many times, live right down the road from there. And again, we like to focus here at Creation Reformation on the New England area. So as much as I can use resources or locations in New England, that's what I'm going to do. So all the locations in Creation Reformation in our YouTube videos, that's our perspective, is we want to bring creationism to New England. So credit to my brother for that excellent picture of a dinosaur footprint. Come see those at Forest Park. But anyway, that's another rabbit hole. We're talking about the fossil record here. The evidence. I've already explained what the evidence is. Fossils appear in the geological column in an ordered fashion. Simple marine fossils tend to appear first. More complex creatures appear later. And land vertebrates, the most complex creatures of all, including man, appear last. That's a brief overview of the entire fossil record. The conventional story suggests that simple organisms are at the bottom first because they evolved first. Simple creatures would have to evolve first and grow more complex over time. The order of the fossil record actually reflects the order of evolution. It's evolution going from simple creatures and producing more and more complex creatures as you go up the chain, starting in the ocean and moving on to land and working your way up that way. If you were to predict the way evolution would occur on a piece of paper, you would say, okay, you have all the animals that exist today. Tell me which ones evolved first. You would take the simplest organisms and put them at the beginning and build up through complexity all the way up until land mammals and humans. And this tends to be what we see in the geological record or the fossil record. You see this general ordering of things. But there is an alternative explanation. The alternative explanation is, again, that these fossils were deposited by the flood, and the order of the fossil record actually follows the order of pre-flood ecology. Deep sea creatures deposited first because the ocean is picking them up from the bottom of the ocean and depositing them on land during the flood. Basically, in our view, tsunamis were picking up sediment from the ocean, depositing them on land, and then another tsunami was picking up another ecosystem, depositing those on land, and then eventually the ones on land get picked up and deposited on top of the ones from the ocean. So you have the order of pre-flood ecology, okay? Which means that the animals that avoided the flood the most are the ones that are more inland, the land mammals, and then the birds, which can fly, are probably going to be fossilized at the end. And so you have the entire order of the fossil record explained by the order of ecosystems that existed when the flood was happening. So when the flood comes through, it deposits them based on their ecology. Oh, this is supposed to be a GIF. That is disappointing. But basically, the way this happens is based on plate tectonics. In the conventional view, plate tectonics happen very, very slowly. This is where new crust is formed. Yeah, it doesn't. I can't get that GIF to go. That is disappointing. But go ahead and go onto our website, creationreformationnewengland.com, and go to the Creationism 101 page. You will see these pictures, and you will see that GIF in motion. Basically, what happens is we see a lot of evidence at the bottom of the ocean that there were these rifts that happened on the seafloor. The ground split apart, and lava, subterranean lava, moved up to the crust, and this basically, the lava hardened into new crust, and this new crust split away from each other. So basically, this is the ground splits, subterranean lava moves up to the top of the crust. It hardens because it's cooled, and this is happening underwater, so it cools pretty quickly and forms new crust. And this new crust then pushes the rest of the old earth, the old crust, away, and you have this divergence where different tectonic plates are moving away from each other. Tectonic plates being the large plates, there's really no better word for it, these large land masses on which the continents sit. So continents sit on top of these land masses. These land masses, called plates, move away from each other as new crust is forming. But if new Earth's crust is forming and moving away from each other, what's going to happen is, you're forming new crust, which means the crust that already exists is going to collide with each other because there's not enough room for everything. So as the plates move away from each other, you're going to get something called subduction. Two tectonic plates run into each other. One plate moves underneath the other plate. And this is that's called subduction. And when subduction happens, the plate that goes underneath the other plate forces lava that is underneath the top plate to rise to the surface, and you get dramatic volcanic eruptions. You also have the plate that is on top. I can just right in front of the camera. The plate that is on top actually, as the plate subducts, the plate on top actually bends because there's friction between the two plates. The top plate bends, but it can't go forever. It can't bend forever. It's actually going to spring back into place eventually. And when it springs back into place, you have dramatic earthquakes. And if you have dramatic earthquakes that are happening underwater, you have tsunamis. So tsunamis, earthquakes, volcanoes, all explained by plate tectonics. And in the conventional model, this has been going on for millions of years, hundreds of millions of years. And every once in a long while, because subduction is so slow, every once in a long while, the top plate buckles and then springs back into place. And that's when you get an earthquake. And that's when you get a tsunami. And the subduction is also how you get volcanic eruptions. But because of its slow rate, volcanic eruptions are rare. Earthquakes are rare. And they're not, they're dramatic, but they're not incredibly dramatic, which is what creationists believe happened during the flood. Catastrophic plate tectonics is the view that creationists subscribe to now. Look at hopefully you're starting to recognize some of the names on this list. Andrew Snelling was on the paper for this. Kurt Wise was on the paper for this. Steve Austin was on the paper for this. These are people who are already at work on the log mat theory. And they published a paper in 1994 that explained the entire catastrophic plate tectonic model, which says that basically continental drift all happened during the flood. You had a continent called Pangaea, where all the continents came together. It's called Pangea, and all the continents basically formed during the flood, and then they broke apart. And when they broke apart, this is the same exact process as conventional science. It's just happening way faster because it's happening during the worldwide flood, which means instead of subduction, you get something called runaway subduction, where the plate is moving much, much, much faster. It causes the top plate to buckle over and over and over again because of the runaway subduction. This is causing ginormous tsunamis because of how fast it's happening. It's causing ginormous earthquakes, and it's causing ginormous volcanic eruptions. And that is where we see tons of evidence for throughout the world. So hopefully that all made sense. You can go ahead and rewind and hear me explain it again and again until you kind of start to get it. But maybe when you look at this evidence, it'll start to make more sense as well. We know tectonics is a thing because we can see the oceanic rifts in the bottom of the floor. That is where the earth split, the crust split, and the lava came up, cooled, and started to make the new crust. And then the new crust pushed these continents apart, away from each other, in what is called a continental sprint, as opposed to a continental drift. Because in the creation model, it's happening really, really fast. Here are even more papers on this that talk about the fossils that have been laid down by these tsunamis. So again, these tsunamis that are being caused by the plate tectonics are going to be picking up ecosystems, depositing them on land. We have evidence of volcanic eruptions in those fossils. We have evidence of let's see. Oh, we have evidence of footprints, vertebrate footprints that always appear before the organisms that belong to those footprints. That's a very interesting fact. If this was something that was happening over millions of years, you would expect fossils to be found anywhere, above, below, next to the footprints that they made. But we actually find footprints always appear first, and then the organisms appear later in the fossil record. And that kind of seems to indicate that the footprints were fossilized first, and then as the floodwaters rose, as the tsunamis came, the creatures were then caught and deposited afterwards, kind of indicating that the animals were running away from something. The footprints also tend to be sloped uphill, so the animals are running away from sea level. I wonder why. So we have evidence of fossils, fossil footprints. We have evidence of volcanic activity, which would be microtectites, tiny little pieces of rock that are burning hot, and they are ejected from volcanic eruptions. And we find those in the lungs of fish. We find them inside of animals, which shows that there were dramatic volcanic eruptions happening at the same time as these animals being deposited, around the same time. So these animals were fossilized pretty much right after they were hit with a hailstorm from a volcanic eruption. Not only is that a really bad day for those fish and those animals, but it also shows that they were buried during some catastrophic events throughout the world. What are the odds that in the secular paradigm, what are the odds that fish would be hit with a volcanic eruption and then buried in a flood at the same time? So here's a paper on catastrophic plate tectonics. You can read that from 1994. It explains everything, more than what I just told you, much, much more, and even more that even I, as if I'm like some brilliant mind. But there's even a lot of stuff in that paper that I don't quite understand, and it would take a more expert geologist. But it's also written in a way that I think if you're good at reading, you'll be able to understand the basic tenets. So go ahead and look up that. The link will be in the description for that. All right, now we can get to, hopefully I explained that well enough for you to get the gist of, but now we're getting into the stuff that hopefully I can explain a lot better, because this is creation biology. This is my area of pseudo expertise, and this is something that I can explain hopefully a lot better. So whereas geology and paleontology tend to happen during the flood, right? All the geology and paleontology we've talked about is happening directly during the flood. Some processes happening afterwards, like Hopi Lake, but pretty much all that evidence is flood caused. Creation biology has to deal with after the flood. So the flood happens, and the scripture says that God called 2 of every kind of animal to Noah to be put on the ark to be preserved, so that they are not all killed during the flood. And so after the flood is where creation biology really happens. This is what we have to look at. So the evidence that we have in biology is that natural selection certainly does occur in nature. We can observe it. We can also observe speciation, one species diversifying into two different species. And we also see that organisms are very well adapted to their environment. So for a long time, the assumption was that God created each species according to their environment and without them needing to change. They're all fixed. But we now know, based on the evidence, that this is not the case. Speciation does occur, species do change, they do evolve to a certain extent, and they are adapted to their environment. So the conventional theory proposes that if given enough time, changes in populations can lead to changes in altogether different creatures. It can create altogether different animals. It can change one kind of animal into another kind of animal. The processes of natural selection and mutation actually cause the organisms to become what they are today from different creatures in the past. Now, I will continue to maintain that just like how our plate tectonics models aren't all that different between the secular model and the creation model, I do also think that our biology model is not all that different from the secular model. Even though we shrink everything to just a few thousand years instead of millions of years, we do believe that biological processes happen and that animals can adapt and evolve to a certain degree. So in this case, the biblical story says that God designed all life in created kinds. What are created kinds? We're still not positive, but we think we have a general idea. He created them in their kinds. And then God designed in those kinds the ability to adapt, diversify, and evolve. He gave them the genetic potential. He gave them the designed and engineered ability to adapt to new conditions and to spread across the world and meet whatever conditions that they find. Darwin observed this process and incorrectly inferred universal common ancestry, that everything is related and that everything has evolved from something else. But what he's actually observing is diversification that is happening within the general kinds that God created. We find evidence of this in a new field of science called baraminology, which is something that creationists can do to try and find out what the created kinds are. The word baramin is Greek for created kind. And what we can do, essentially, is we can identify which groups of animals are essentially the same type of animal. And when we do that, we also find, and we do this through genetics, which is called systematic baraminology. We can also do it through looking at morphological traits and what traits an animal has and what traits it doesn't have. Either way, we can identify not just the way the animals are similar, which is what secular phylogenetics does, but we can also find out how the animals are different. And we can also take in something called discontinuity into account. So the strength of baraminology is it does not just observe the similarities between organisms, which is what evolutionary phylogenetics does. It also can account for their differences. They are similar in that maybe they're part of the same created kind, so the same type of animal. But then when we notice discontinuity, this indicates that the two animals might be from different created kinds. And so we can do this and narrow down what the created kinds possibly were. Okay, so here's an example. This is from 2007. This is marsupial lions. Okay, each of those species listed is marsupial lions. And so what this person did, and this is how baraminology is done, you basically line up all the species of marsupial lions. And you put them in a line down the left side of your scatter plot, which is what this is called. Put them down the left side, and then what you also do, they're also lined up, and this is imaginary, but you have to think, this is lined up horizontally at the top of the box as well. So if you look at the bottom name is Catapolosis. Catapolosis is the row at the very bottom, the horizontal row at the bottom. But Catalopus is also the vertical line all the way to the left of the square, because also if you look all the way to the left, all the circles and squares, it goes down the left side there. So which means the bottom left corner, that square, is Caudipilosis being compared to Caudipilosis, being compared to itself. That line that goes through, bump my mic, that line that goes through the square, those boxes that are in that line represent each species being compared to itself to see whether or not it is within the same kind. Obviously, the species is in the same kind as itself. Then you can look at that species and go the next. So let's look at the bottom left, Caudipilosis. Caudipilosis is in the same created kind as itself. That's why there's a line running through it. Then look at the square to its left. The square to its left is Caudipilosis being compared to the next species over, Trichosaurus. So Caudipilosis and Trichosaurus. And the square represents continuity. It means that those two organisms share all their physical traits, or they share the same genetic markers. So we put that square there for continuity. There is continuity between these two species. They are probably in the same created kind. Then we can look at Caudipilosis and that bottom row, move one more over, and now you're comparing Caudipilosis and Liticoala. Are Caudipilosis and Liticoala, do they have continuity or do they have discontinuity? And if you line up these species in such a way they will cluster together in that they make these big boxes of squares that show all these organisms are continuous with one another. But then eventually you're going to hit a discontinuity, and that's what the circles represent, which means that they aren't just not continuous, they are also discontinuous. They also have different traits and different genetics that indicate that they are not in the same created kind. They are not continuous with one another. So this is a little confusing, but if you study this graph and you remember that these species are lined up both horizontally and vertically to the point where they all match up with each other down the middle, kind of like in a multiplication table, you can figure out that these boxes, these larger squares, show continuity between species. And we can look at that and say, these species are similar enough, they must be in the same created kind. These animals are very different, maybe they're not in the created kind. And we can see which species diversified from a common ancestor that was on the ark, and which species do not match and came from different creatures on the ark. And then we create our own little phylogenetic trees that aren't really phylogenetics, but they're baraminology. They are trees of different created kinds. And we believe there's a horse kind, we believe there's a bear kind, we believe there's a dog kind, we believe there's a cat kind. And that's how that comes up with there. So each of these, if you go back here, if we put a chart and lined up all the cats and lined up all the dogs together, we would see a giant box of squares for the dogs and a giant box of squares for the cats showing continuity, but we would see discontinuity between the dogs and the cats because they are different. They are in different created kinds. Hopefully that makes somewhat sense, but we see evidence of both continuity and discontinuity in baraminology. We do not see a continuous chain linking all animals together, which is what you'd expect if everything had a common ancestor. Now, baraminology is not a proven field, so it is very much criticized by mainstream scientists as not a valid field of scientific work. But what we cannot deny, I don't think, even if baraminology is not a proven field that we know works, I do think what it has done is shown that animals cluster together. They cluster and show similarities, and then they show discontinuity with other animals. And at that very bare minimum, that does show that the evolution story is not perfect, because you would expect there to be continuity between everything, because everything shares a common ancestor and evolved step by step together. All right, finally, we're in the home stretch now. My last piece of evidence here is evidence of rapid adaptation in species. So since we have created kinds that left the ark and diversified, we need a mechanism. We need to explain how they adapted so quickly, because we only have a few thousand years, right? We go from the Ark to today for like 4,500 years. So in that timeline, we need animals to diversify and speciate really, really quickly for evolutionary terms. So that's something that has to happen. And so creationists would expect to see that. And evolutionists actually wouldn't expect to see that so much. In their model, evolution happens really slowly. It's a very gradual change, and it takes lots and lots of time. So what we're actually finding is that evolutionists are discovering rapid adaptations and rapid evolution, really. It's change over time. It's rapid changes, and they're finding it on accident because they weren't really looking for it. But it's happening really, really quickly, much faster than they thought. So these are each, I'm going to show you the sources I have on each of these, but we've seen in the past couple decades, we've seen a new species of finch in just about 50 years. That's one of Darwin's finches. It's on the Galapagos, actually. We saw a new species of finch arise from hybridization in just 50 years. We've seen extreme adaptations of cave fish and cave salamanders in over a pretty short period of time. We've seen, this is a quote, dramatic evolution of hymenopteran insect species with preserved features in the genome. So we're seeing we're seeing traits that just pop up in the genome from genes that were already there. They just weren't being expressed, which means it looks like really, really rapid evolution, as if it was designed or engineered to adapt to new conditions. And these are, all three of these are from non-creationist resources. So I'll again put these articles in the description, and they will never actually, these are not creation researchers. This is something that evolutionists are stumbling upon, and they weren't looking for it because in their minds evolution always happens slowly. But if you're a creationist, your prediction would be, you would expect that the evolutionary processes, at least the processes you agree with the evolutionist on, like natural selection, you would expect them to happen much faster. You have rapid diet adaptation in herbivores with, quote, resource control. So in other words, the herbivores are almost controlling their own morphology and pretty much immediately adapting to conditions based on their needs, right? Their physical needs. If they need to digest certain types of food they couldn't digest before, they are adapting to it based on like almost self-control. They're almost controlling it themselves, like they can evolve on their own. We have rapid adaptation of invertebrate pests to climate stress. So climate changes and invertebrate pests adapt pretty quickly, unfortunately for us who have to deal with the pests. We have rapid adaptation in response to new environments, such as metabolism changing, growth rate changing. Again, here are these papers. So these are scientists who are reporting on these things, and this is something creationists would have predicted and evolutionists would not have predicted. Take a look at this paper from Rapid Adaptation and Conservation. I'm sorry, that's not the paper. The paper is Conservation Biology. The title is Rapid Adaptation and Conservation. They say that, quote, recent work has demonstrated that adaptive evolution often occurs on contemporary time scales from just years to decades, making it of particular relevance to conservation planning. Reports of rapid evolution span a variety of species, traits, and situations, suggesting that rapid adaptation is the norm rather than the exception. So they're discovering that it is more normal for a species to rapidly adapt to change than it is for it to happen slowly. It's the norm rather than the exception. So this is, every time you see a phrase rapid evolution or rapid adaptation or contemporary evolution or any of these things, that's something that a creationist needs to point at and say, aha, I knew it. That's exactly what we'd expect to happen. This is a different paper. Rapid Evolution, Introduced Species, Invasive Traits and Recipient Communities, Challenges for Predicting Invasive Potential, from Diversity and Distributions in 2008. They say these evolutionary changes include rapid adaptation of invaders to new environments, effects of hybridization, and evolution in recipient communities. Strikingly, we document 38 species in which the specific traits commonly associated with invasive potential have themselves undergone evolutionary change following introduction, in some cases over short, under or equal to 10-year timescales. That is incredibly rapid change, and that's exactly what creationists need. It's what we predicted. It's what we desperately need to see in order for our model to be even somewhat plausible, and that's exactly what they're finding. And there are many more papers like that. I will probably have some form of seminar or presentation uploaded to the New Creation YouTube channel about that topic itself. That has been my kind of specialty in the creation science sphere. I presented at the Creation Research Society about evidence for rapid diversification. And so that's something that I will have uploaded here at the Creation Reformation. So keep an eye out on that, because that's kind of my area of expertise, you could say. I've read many papers on it. And as a great scientist once said, if you read 20 papers, scientific papers on a subject, you then become an expert. So I can say, if nothing else, I'm an expert on rapid adaptation or rapid speciation in that way. And so I'll have more on that on this channel. But we got to wrap up here. I named this part 2 Wrath and Redemption because we can see that geology, paleontology, and biology always have multiple interpretations. And even though a lot of it is explained very well by evolution theory, we also see that scientific research that values the biblical account of world history, in other words, takes into account that a worldwide flood happened. These projects have led to good scientific models and have led to confirmed predictions. And again, I'll say this over and over and over again. Even though it is true that just because a theory explains data well, it does not make a theory true, even though that is true, I will say that if the Bible was completely scientifically errant, completely mythological in nature, we should not be getting the results that we're getting. Okay? And if I were to go back in time, not even go back in time, I'm sorry, if today I were to look back in time and say, let's build scientific models based on Old Norse mythology, and I were to take Norse mythology and I was going to say, because Zeus is a god of lightning, let me go out and make scientific observations about lightning, and I think I can prove, and I can make these predictions, and I can prove these things because, in my mind, Zeus is the god of lightning. I'm not making it very far in the scientific realm. There's no real papers you can publish that is good scientific research based on the premise that Thor exists and he's the god of lightning, and if I read his mythology, then I'll know this about the world. There is no scientific theory that can be built based on just based on the Egyptian gods or based on the Homer and the Iliad and Odyssey. I can't look back at those, not that they say much about science, but hopefully you can get my meaning, that we can't look at these ancient pagan texts and build scientific models based on the history of those texts. So if the Bible is just one of those pagan religions, if it's just one of those myths of the Near East, we shouldn't be able to build scientific models off of them. But when we do, we're getting good results. We're getting good explanations based on accounts written in the Bible of the flood. And that's remarkable, I think. And I think that's something that should give creationists hope for that the future is bright. Because if the secularists are right, the Bible is not true, it's completely scientifically bunk, and evolution is the way things happened, then we should have been stopped in our tracks a long time ago. Now, some would argue we have been stopped in our tracks, but I think there's in my opinion, looking at it, being involved in the creation research for a few years now, I think this stuff holds up. And that should be an encouragement to us as Christians, as creationists, and as people who value biblical history. So my third point, creationists should not fear discovery or evidence, but should instead seek to answer questions scientifically. The future of creationism is bright. And as a final remark, this seminar was titled Wrath and Redemption, and it was titled that because I hope you see, as we describe the flood event, and I definitely stressed this more the first time I gave this seminar at PDCA, but I'll stress it right here as a closing thought. When you look at how creationists have explained things and the evidence they found evidence of ginormous volcanic eruptions, evidence of ginormous tsunamis wiping out the earth. We find evidence of earthquakes. And of course, we find evidence of flood deposits, right? Flood picking up sediments, depositing creatures by the billions. Okay, this is God's wrath. Okay, we are scientifically observing the wrath of God. Right? When we look at this, we are not seeing a snapshot of millions of years of creatures living, in the past. We're seeing a snapshot of what God's wrath is capable of as he completely reshaped and wiped out the creation he had made. Right? Scripture says he regretted making man and the creation that he had made. He regretted it because that's how evil men were, and so he wiped it out. And that is the wrath of God. But what we also see is the speciation happening after the flood. We've seen that something survived, that he preserved the ark full of two of every kind and full of one human family. And he preserved them because his ultimate plan is to redeem this creation. And he had to preserve something in order to do that. So just as Darwin said there is grandeur in the view of life, that all things have a common ancestor and have evolved, I would say that there is a grandeur in this view of life as well. That despite the wrath of God on the wicked, a wrath that fell on all of life, not just man, a wrath that completely covered and destroyed and demolished all of creation, that despite this wrath, God also designed in life the ability to replenish, to fill the earth. He designed in them the genetic potential to adapt to new environments with ease. And he built creation to last. He has preserved this remnant that he saved during the flood. And he gave his people a second chance at being his representatives on earth. Right? Of course, this second chance, we're not doing too hot either. Okay? But he has preserved us to fill the earth, to be his representatives. And ultimately, we will never actually achieve that goal of being God's perfect stewards until Christ himself comes in and redeems the world. But he preserved it. He kept humans alive and he kept the animals alive because he plans ultimately to come back and redeem his creation. So there was a lot of science today, a lot of technical descriptions of science. But at the end of the day, we must not remember what story we're actually telling here. And the story that is being told is one of wrath and one of redemption. And what is most exciting about being a creation scientist is that not only do we learn about the world, but we also learn about this biblical story. And we also can understand the narrative of the Bible that better because of this scientific research, because we have learned truly what the wrath of God looks like by looking at the flood and the evidence for it. We can have a better appreciation, a better understanding of the biblical narrative, which is that God truly brought his wrath down, rained his wrath down on his creation, but he did preserve a remnant, and that remnant he designed to replenish and to fill the earth for the ultimate goal of redemption. So that'll do it for part 2. Thank you for watching. This was a even longer video than part 1, but hopefully you have a better understanding of the creation model and keep tabs on Creation Reformation. We have resources out there. If you have any questions, if some of my explanations were completely wacky and you had a hard time following them, go on to our website, read the Creationism 101 page there. That has at least been reviewed by creation geologists and paleontologists who are experts and know more than I do. They've reviewed that. Another thing you can do is get Paul Garner's book, The New Creationism, which breaks down even more the general creation model. And he covers things that like radiometric dating, and he dives into way more than this seminar did. But his book is kind of that same vein, right? This is what creation science looks like. And so I highly recommend that. But I'll leave you be for now. That was part 2, Wrath of Redemption. Stay tuned for part 3, where I'll dive into what creationism looks like today, or why it's a better alternative to other philosophical worldviews that are out there today. We'll compare them, look at the philosophy of that. Thank you for watching. Appreciate you. Keep tabs on Creation Reformation. Keep tabs on our website. Subscribe to our newsletter. And this is Jake Ramgren with his book on his series, Why Reformation. And see you next time.